When it comes to metal parts and equipment, we're happy when they work well and last a long time without repair or replacement. Lambda Technologies, a small firm in Cincinnati, Ohio, has developed a process to help make that possible. It's called low plasticity burnishing, or LPB. The burnishing process has actually been around for a long time.
A burnished finish is like a polished finish, only it's done by smoothing the surface mechanically as opposed to grinding away finer and finer layers like you would with the grinding grit, to polish something.
LPB increases the fatigue life and performance of critical metallic pieces without changing the material or design. Through NASA's Small Business Research contracts, Lambda teamed with Glenn Research Center. They demonstrated that the LPB process worked well on metal alloys that might be used on supersonic transports. The work led to a Space Act agreement with Glenn, and Lambda developed a robotic tool for the LPB process during that time. Unlike other burnishing processes, LPB uses a single pass on the surface, minimizing the amount of work to be done, and yet still improve the fatigue performance of the object, such as a fan blade. And with LPB, the force being applied to the tool is synchronized with where the tool is positioned on the surface.
This process is the only one that I'm aware of which is closed-loop controlled. We can monitor the pressure applied, the force applied, at the tip of the tool continuously, and monitor that by computer.
Lambda has worked with NASA, the Air Force, and the Navy to improve the fatigue life of aerospace components made from superalloys. By being able to impact the exact amount of strength needed to resist loads, corrosion, service, damage, and other problems, LPB can improve fatigue durability in airframes and engines. In 2009, Lambda and Delta Airlines signed an exclusive agreement to use LPB for maintaining aircraft components. That same year, the Federal Aviation Administration accepted LPB as a service enhancement treatment for the improvement of fatigue performance in aircraft components.
They have a fleet of the MD-88s, but the interest was to use this as also not just for their own fleet, but as a commercial process to team with us to get this into, to make it available for the other airlines.
LPB has also been transferred to a medical application. Exactech, a manufacturer of orthopedic implant devices, uses an LPB component in its hip replacement devices. The neck segment, which connects the femoral stem to the hip piece, can experience a lot of wear and tear during the course of a day. However, testing shows the LPB neck with 30% improvement.
We were able to burnish just this portion, in a lathe actually during manufacture, and completely eliminate the fretting-induced fatigue failures.
Which translates into longer-lasting, more cost-effective devices, making both doctors and patients happy.